So to find the equation of a tangent line to the graph of the given function, let's review a little bit of algebra real quick and just how to write the equation of a line. To write the equation of a line, I will use something called the point-slope formula. And it goes like y minus y sub 1 equals the slope times x minus x sub 1. And there's some good news here because I already got a good bit of this information. I have y minus my y value that I am getting from, from right here, okay? This is my x value. So y minus 1, y minus a positive 1 equals the slope times x minus the x value was a negative 1. I'll simplify that a little bit. I'm not really trying to do all that right now, but it's bugging me, that minus and negative. Anyway, so this is all algebra, okay? But here's the calculus, because we need the slope. We need the slope to finish out and write the equation of this line. That's all you need for a line, by the way, is a point and a slope. So we are going to get the slope. You get the slope of a tangent line by taking the derivative, f prime, taking the derivative and plugging in your x value that it gave you, okay? So f prime of x is a derivative, and anyway, I put that negative 1 there in place of x. All you do is find that derivative and plug negative 1 into it, and that will be your number for the slope. Okay, so this is where the calculus is, where we're finding this derivative. Okay, so the only way we know how to find a derivative right now is to evaluate the limit as x approaches 0 of the difference quotient, which is f of x plus h minus f of x all over h. And here's a little issue that we have. We have what f of x is, but we don't know what f of x plus h is. We're going to have to find that, and h is just h. So to find f of x plus h, I am going to take what f of x is. F of x is negative x cubed. So that means f of something is negative something cubed. So that means that f of x plus h is negative x plus h cubed. I need to simplify that. You need to cube that out. I will start with these back two, and this is a FOIL method. So x times x is x squared, x times h is xh, h times x is xh or hx, it's the same thing. H times h is h squared. That simplifies into x squared plus 2xh's plus h squared. And then you have your negative and your x plus h still. Okay, well now let's worry about distributing the x plus h to the trinomial behind it. So I'm going to say x times x squared and x times 2xh and x times h squared to get x cubed plus 2x squared h's plus xh squared. And now I will distribute the h to the x squared and 2xh and h squared to get hx squared 2xh squared, and h times h is h squared. Excuse me, h times h squared is h cubed. Now you just got that negative out front, but I do want to simplify the inside as in combine the like terms. There's only one x cubed. X squared h's. X squared h's. We got a 2x squared h and a hx squared. Those are like terms. That is 3x squared h's. And then we have an xh squared and 2xh squareds. So that is 3xh squareds. And then all you're left with is that h cubed in the back. And now just change the sign of everything. And I said change the sign of everything, but I didn't really do it. Okay, so now we've found what f of x plus h is. I'm ready to figure out my derivative, so then I can plug in the -1 into the derivative so that I will know what the slope is, and then I can plug that into the equation for a line. Anyway, so the limit as x approaches 0 of the difference quotient. So if we've done if you do the difference quotient correctly, it really makes you happy, because there's a whole lot of cancellation, and it just is a whole lot of stress relief. So hopefully that's what happens. So let's write down our f of x plus h, which we just found to be -x cubed minus 3x squared h minus 3xh squared minus h cubed. Now we're going to subtract our f of x, which is -x cubed all over h. Okay, so this is what I'm talking about with the cancellation. This is really a minus and negative, so a positive x cubed, which cancels with that and leaves you with -3x squared h minus 3xh squared minus h cubed all over h. And all of these have an h, right? So this h will cancel 1 from each of those terms to give me -3x squared minus 3xh minus h squared. And there's no denominator anymore. Since I've had that, and here's another reason. If you don't see that this h canceled all of these, think of another step being to factor out that h in the numerator. That GCF of h, and you're left with -3x squared minus 3xh minus h squared all over h, and these h's cancel to leave me where I'm at right here. So since I had that cancellation between the numerator and the denominator, I'm ready to evaluate the limit. So if you plug a 0 in for h, you get -3x squared minus 3x times 0 minus 0 squared, which is just -3x squared. This is equal to f prime of x. This is equal to the derivative. I need to know the slope, which is not necessarily f prime x. It's plugging the x value into f prime x. It's using the derivative. The slope is not the derivative. You use the derivative to find the slope. So I'm going to plug this -1. I'm going to find f of f prime -1, which is negative 3 times negative 1 squared, which is negative 3 times 1, which is negative 3, and that is the slope. So now, I can finally go back to the algebra of this and say y minus 1 equals negative 3 times x plus 1. Y minus 1 equals negative 3x minus 3, and get y by itself. There is your answer.